Hello everyone, my name is Satyanarayana Swami and today I'm reviewing the research paper of Resilient Distributed Dataset, a fault tolerance abstraction for in-memory clustered computing. And here I'm covering the topics of in this research paper. What is the problem? Why is it important? Is it a hard problem? What is the novelty? What is the main contribution? What is your approach? What is your validation? Coming to my first point, what is the problem? The main problem addressed in the paper is in the area of the big data processing, the scalability and fault tolerance of the distributed computing framework plays a pivot role in ensuring the efficient and relatable data processing. To overcome these limitations, the paper is proposing Spark, which leverages resilient RDDS as a fundamental abstraction for distributed data processing. The RDDS is distributed datasets. And the second, is it clear stated? Yeah, the problem is clearly stated by giving the enough examples stating the importance of building the RDDS to overcome and addresses the limitations of current shortcoming of exciting systems. Resilient distributed datasets. A fault-tolerant abstraction for in-memory cluster computing introduces the Spark, a powerful distributed computing framework designed. The implementation and elevations is clearly stated in the paper with enough example. The third point, does the author makes the important issue clear? Yeah, the important issue in the existing system are clearly distributed in the paper. There are bad for interactive analysis and iterative algorithms, poor support for in-memory process computation, low fault tolerance. And coming to the first, bad for interactive analysis and iterative algorithms, many generalized clustered computing frameworks like MapReduces and DRAID lack in two areas: iterative algorithms and interactive data analysis. And coming to the second point, this current shared memory system relied on replication to achieve fault tolerance. Replication is expensive. And coming to the third point, existing abstraction for in-memory storage on clusters such as distributed shared memory, key value stores, databases, and Piccolo offered an interface based on fine-grained update to mutable state. Hence, they offered low fault tolerance. Why is it important? Is the problem significant relevant? Yeah, the problem is significant because it helps programmer perform in-memory computations on large clustered in a fault tolerance manner. Here they are recording the linear age of an RDD. Keep the DAG of transformation applied to your basis RDDS. RDDS can be recomputed by retracing the steps in the DAG. Here we clearly mention in the diagram. Is the problem significant relevant? The problem is significant because RDDS provides the efficient computation and data reuse for both iterative algorithms and interactive data mining tools. And the steps are: modern data analysis involved iterations. Users also want to do interactive data mining. In both cases, want to keep intermediate data in memory and reuse it. MapReducer does not support the scenario well. Hence, we required RDDS for solving these problems. And the RDDS expensive enough to capture the wide classes of computation for iterative jobs such as Pregal with in-memory progress computation. RDDS can be kept in memory. Trade-offs against the distributed shared memory DSM. No, no arbitrary updates, immutability. Can run back copies of jobs and can schedule based on data locality. Is there are any reason to care about the problem? Yes, the paper did provide the information about the real-time user application built with Spark RDS such as in-memory analytics, traffic modeling. Is there any reason to care about the problem? Yes, the paper did provide the information about the real-time user applied built with the Spark RDS such as Twitter spam classification. Who shows the scaling result for training in a classifier over a 50 GB subset of the data? 250,000 URLs and 107 featured dimensions related to the network and contained properties of the pages at each URL. The scaling is not as close to linear due to high flexed communication cost per iteration. And the interactive data mining. The image shows the response time of the queries on the full dataset and half and one-tenth of the data. Even in 1 terabyte of data, queries a Spark took 5 to 7 seconds. Is the problem new? The concept of RDDS was a novel contribution at the time of the paper's publication, which in 2012. RDDS addresses the challenges related to fault tolerance and efficient distributed processing in the context of in-memory clustered computing. However, it's important to note that the field of distributed computing is dynamic and developed maybe have occurred now. What is the difficulties of solving the problems? There are three difficulties. There are computationally complex, large search space, hard to solve. In the computation progress, there are fault tolerance in the process of the operating state. Yes, it's a complex. RDS maintaining fault tolerance because complex when operations have associated state that need to be preserved in case of node feature. Large scale space. Scalability. Yes, RDS need to be designed to scale horizontally and efficiently. Distributed computation across a growing number of nodes in the cluster. Hard to solve? Yeah. Efficient recovery of a lost data. Yes, it's a hard to main challenge is designing RDS is defining a programming interface that can prove fault tolerance efficiently. Has the problem been solved before? Before the paper published, there were various approaches and solutions of distributed computing and fault tolerance. But RDS as distributed in the paper represented a specific contribution to the space. Is the trivial variation or on or extension of the previous results? It's common in research and technology for solving to build on early works, and RDS were designed to address the certain challenges and limitations in exciting approaches. Is the author aware of related and previous work, both recent and old? In the paper, the author did study the previous work on distributed shared memory and presented the difference between RDDS and distributed shared memory as follows. It was represented in the below table. What are the limitations of the related work? What is the novelty? What are the assumptions and limitations of related work? Below are some limitations and assumptions of the related work which the author is trying to overcome with RDDS. Clustered programming model. Related works in clustered programming model falls into several classes, and the caching systems. Nectar can reuse the intermediate results across the trade line queue job by identifying the common sub-expansion which program analysis. The capability would be complaining to add an RDDS based system. Linear edge. RDDS provide a parallel programming model where fine-grained linear in expenses to capture so that it can be used for failure recovery. In contrast, RDDS apply linear edge to present in memory data efficiently across the computation without the cost of replication and disk I/O. 5. Which limitations is solving in the paper? Relational database. RDDS are conceptually similar to viewing in a database, and present RDDS resemble materialized views. The overhead are not required with the coarse-grained transformation model of RDDS. This is the main limitation of the related work which is solving in the paper. Is the problem that extension of the related work? Which part is the extended? This was in the what are the contributions? The problem is the enhancement of the exciting distribution computing by adding the efficient general purposes and fault tolerance abstraction for sharing the data in a clustered application. Fault tolerance and efficient is the extension and part. Is the problem new? The problem is new during the time of paper published, which was 2012. What are the contributions? What are the proposed approaches, algorithms, and ideas? Transformations are lazy operation used to build the DAG, example map, filter, reduce, sample, join, group by, sort, etc. General can express the map reduced in Spark. What are the proposed approaches, algorithms, and ideas? It was represented in the below table. Transformations and actions. What are the proposed approaches, algorithms, and ideas? What are the proposed approaches, algorithms, and ideas? Narrow definitions. Narrow Narrow dependencies, each parent RDD partition used by at most one child. We can pipeline computation of multiple narrow dependencies. Example, compute map followed by filter on a per element basis, for example. Wide dependencies. Wide dependencies, multiple child partitions may depend on a parent RDD. All data from all parents must be available. Joins may be either narrow or wide, depending on how parents are partitioned. What are the contributions? Is there any experimental and analytical elevations? The Spark RDDS is validated against the Hadoop and Hadoop bin meme, and it outperformed for following reasons. Minimum overhead of Hadoop Stark, as a Hadoop inserts around 25 seconds of overhead to complete the minimum requirement of job setup, starting task and cleanup. Note that Hadoop bin meme converted input data to low overhead binary format and stored it in the memory HDFS instance. What are the validation methodology? Case study. The case study mentioned in the paper of Spark implementations. Spark stage. Job scheduling. Spark scheduling used or representing of RDDS, interpretation integration, memory management, support for checkpointing, statistical hypothesis testing. The paper evaluated the Spark and RDDS through a series of the expenses on Amazon EC2 as well as benchmark of using applications. Overall, the results shown the following. Spark outperformed Hadoop by up to 20x in iterative machine learning under the graph application written by our user performed and scale well. In particular, we used Spark to speed up an analytics report that was running on Hadoop by 40x. Analytical elevation, iterative machine learning application. The implementation of the two iterative machine learning application, logistic regression and k-means to compare the performance of the following system. Hadoop. The Hadoop 0.20.2 stage release. Hadoop bin meme. A Hadoop development that converts the input data in a low overhead binary format in the first iteration to eliminate text parsing in later ones. Spark. Our implementation of RDDS. By storing RDD elements directly as Java object in memory, Spark avoided all these overheads. What is the validation of methodology? Computational complexity RDDS achieving the computational complexities as below. Finally, to illustrate how the model achieves the fault tolerance, we shown in the lineage graph for the RDDS in our third query in image. 5. Theorem and Lemus proofs. The methodology following below steps. HDF file. Map, union, sample, join. Experimental elevation. Page rank. In the paper, the methodology elevation a various of page rank written using the implementation of the Pregel over Spark. The stage of the weakness of the methodology. The stages of the methodology. Inbuilt operation RDDS, a runtime can schedule the task based on data locality to improve the performance. Weaknesses of the methodology. Lots of turning, manually controlled partitioning and memory presence. Only one contrived experiment of fault recovery time. Batching is the default assumption. Low-level programming model. Why did author chooses this methodology? The author chooses the methodology because RDDS provided the interface based on the coarse grained transformation that allowed them to efficiently provide the fault tolerance by logging the transformation used the build as dataset. RDDS can efficiently express the many cluster programming model that have to so far for being progressed as the separate system, including the map reduces, SQL, Pregel, and Hadoop, as well as the new application that these systems do not capture, like interactive data mining. In summary, Performing improvement these in the memory computation, fault tolerance and efficient data recovery, flexibility, user control, scalable across the clustered elevation, real real world user class and application. References. Thank you.